It's great to be here. Thank you for having me come and speak. Full disclosure, I am not an optical engineer. Sometimes I play one on television, but I am a packet head. I have been building IP networks for a long time, and it's great to come and address you. A little bit of history. 16 years ago, the company I founded, At Home Network, turned on its first production broadband market. Working with TCI cable, we activated a city, Fremont, California, up in the San Francisco Bay Area. We delivered about 4 or 5 megabits per second of downstream service for about $40 a month. At the time, this was a step function increase in performance. It was about 100 times faster than what you could get off of dial-up networks. And all manner of new applications began to emerge. I remember actually in those days, people said, what could you do with 4 or 5 megabits? It's totally too much. The web is all designed to deal with dial-up. What's the point? Consumers would never buy into this kind of system. In fact, I remember having a discussion with some folks at AOL about trying to get them to market cable modem service to their users, and they had concluded that broadband was not really a mass market product. They had done a bunch of surveys asking questions like, would you pay $40 a month to download your email 100 times faster? And of course, people said, well, no. And so they concluded that really not an interesting product. It was interesting because when we started rolling this out, people did much of what they did before, just a lot faster. It was always on. And as the network began getting built out and more broadband was deployed, we began to see new sets of services emerge. Video, deliver via IP, websites that had very rich media on them. I'll tell you a funny story. I have a friend of mine who was one of the authors of the Network News Transfer Protocol, NNTP. Back when Mozilla came out, he called me, because I was working for NASA, and said, this thing, the web browser, has got to be stopped. I'm like, why? Why should we stop it? It's going to destroy the network. Have you seen this thing? It allows you to put graphics in pages. It's incredibly wasteful of bandwidth. And he wanted the government to do something about it, which was funny. The fact is that putting rich media in the web made it much more accessible to normal people, right? Folks who didn't know how to use FTP and Telnet, and made the web much more something that was friendly. We also saw things like Napster. In fact, in the at-home days, we used NetFlow processing to actually look for new sources of traffic, what protocols were being delivered over the network, and talk to our business development group about, oh, maybe we should work together. We saw this thing just take off like a rocket. And what was it? We eventually called the founders in and said, what exactly are you doing? And it was, well, we're doing file sharing of music. And it was obvious the business model was illegal, so we didn't go any farther than that. But it was amazing to actually see new sets of services roll out. And the usage on an average basis by consumers began to dramatically rise. 4 years later, 1 million cable modem subscribers were connected in North America, and broadband really began to take off. But in order to deal with this really strong growth, we actually had to do a lot of work on the infrastructure side to change the architecture of the network we built to reduce cost. We had launched the product using an ATM network from Sprint to try and variabilize our cost structures, and that was clearly not going to scale. So we went to a different kind of architecture. I pulled this chart out of a slide deck I had back in 1998 in a presentation to cable operator partners about how we were going to eliminate layers and actually go to IP directly over optical. At the time, this was not considered the normal way you did things, but we felt we could cut out a bunch of costs by eliminating layers and having the routers actually provide protection and all the other things that people expected from ATM and SONET layers. About 6 months later, we turned on the new backbone. That's the dark lines there were OC48s, and the thinner pink lines were OC12s. In the next 6 months after that, it became an all OC48 network running with routers directly plugged into the WDM transceivers. The reason I bring this up is not just because of historical fun, but going to this new architecture allowed us to trim costs from about $6 a sub a month in terms of what the cost of delivery of broadband internet service was to less than $2 a month, dramatically lowering the price of the transport in the system. Over the last decade, technology has continued to inspire dramatic growth in network capacity, while costs have continued to decline. Advances in optical technology have taken capacities well beyond what experts had kind of originally thought. There's a lot of conduit, there's a lot of fiber that is dark today because it hasn't need to be lit. I remember conversations with folks constructing new rights-of-way where multiple tubes of conduit that could each carry 144 strands of fiber were being deployed. And most of that today is still empty because of the work many of you in this room have pioneered, delivering more and more capacity off the existing fiber infrastructures at lower and lower costs. Basically, because of this, costs have continued to decline so that the next increment of network capacity that's added is added at a much lower cost than the increment before. And this has created what I call the age of bandwidth abundance, right? Where new services and capabilities have been deployed in the network. Consumers have been able to enjoy that, driving better demand for broadband access and a great ecosystem of products and services. Some have begun to question whether or not this age of abundance is going to continue. We've seen folks talk about exafloods and future collapse of the internet because we have costs are exploding on the transmission side, and that we have to go to different kind of pricing structures, more usage-based billing to effectively kind of ration network capacity on the broadband networks, putting in place volume limits and a whole set of other things to basically deal with trying to find ways of controlling cost. Google is a relatively large infrastructure provider. This was not consistent with the kind of experience we were seeing in terms of costs and pricing. And so we commissioned a study on broadband economics in 2011. Scott Marcus and Alessandro Monti from WIC Consult released it last year, and it's available there. The study found a bunch of interesting data, and explosive cost growth has not in fact happened and is likely not going to happen, at least in the foreseeable future. Here's an interesting chart. On the left-hand axis, you see the price per megabit of WDM equipment and the amount of megabits actually being shipped. So what we're seeing is capacity has dramatically increased, but the prices have basically remained flat. We don't see an explosion in transmission equipment pricing because of the competitive market, because of innovative technologies coming along. And so basically, the price per bit continues to decline and is projected to maintain that descent. If you look back, oh, that's interesting. There was a slide in here that's missing that actually had a similar chart for the routers. And the routers actually are showing a very similar cost structure in terms of decline. Going forward or backward, I'm being jammed. Okay. There's the slide about router performance. And so again, you can see very high-end router economics, prices per megabit of switching capacity, and the amount of units being shipped. Again, relatively flat. So if one believes that the price of transport has remained relatively stable while capacity has increased, and the same is true on the router side, then we should see corresponding decreases in wholesale transit pricing, because that's the best result of these two factors. And in fact, that's exactly what we see. My friend Bill Norton, who runs the website drpeering.net, has tracked internet transit prices for many years. I remember, I am old enough to remember buying products like that back in the 90s, and we see the decline of transit pricing from $1,200 bucks a megabit back in 1998 to $120 a megabit in 2004, down to about $3 bucks a megabit today, and continuing to go down. This is exactly what you would expect if the cost of the transmission and switching equipment on a per megabit basis has fallen. Prices go down. And from the OFC report, we can see this even more directly. IP traffic has been growing very rapidly. We all have seen that. There are two factors, of course, behind IP traffic growth. One of them is the number of subscribers that are attached, and the second factor is the amount of bandwidth per subscriber that's consumed. So we see the IP transport going up dramatically. Edge service provider edge revenue and core revenues not going up dramatically, right? Prices basically are tracking subscriber additions and not traffic. Again, because of the great work in keeping costs under control. The system is scaling extremely well, has scaled well, and has created the kind of internet that we know and love today. Access capacity prices are also decreasing as speeds are increasing. We see here OECD data from 2011 that shows over the last 5 years what has happened in terms of price per megabit paid. Here, this chart is cable broadband retail prices in a number of countries, right? And we see prices coming down. Revenues, again, ARPU remains about the same. Speeds are going up. People are purchasing higher tiers of service, but not paying that much more for those higher tiers, right? And so we see the effect on dollars per megabit per month showing up here. And on the DSL and fiber side, again, we see similar sort of statistics, right? Where in many countries, cable and the telcos compete with each other, holding pricing down and delivering a race to who can provide consumers higher speeds. Consumer use of broadband has really changed dramatically because of flat rate pricing. This is one of the things that we certainly believed was important back in 19 1996 when we turned on cable broadband service. Most consumers don't know what a gigabyte is. If you ask them, you can imagine the conversation with a call center rep. Excuse me, but my bill indicates that I've got this extra charge. Why is it big this month? Well, you exceeded your quota, and you are now went into the next tier, and we charged you this for that. And it's like, well, what did I do to do that? Well, I don't know. Well, how do I prevent it from happening again? Well, you need to moderate your consumption. But what is it that I did that generated that bandwidth? Well, I don't know, sir. It's an interesting conversation to have, and teaching people about this is going to be an interesting challenge. Because of the low cost to deliver content and services to consumers, whole new classes of services have been able to flourish. Because consumers basically didn't have to worry about this issue of what if I click on this file or I stream this video, what's it going to do to my bill? And that's really empowered services like YouTube and Netflix to come into the market and create great products for consumers. One of the things that is often talked about in this discussion is the nature of how content providers are basically using all these pipes, right? Using up all the capacity and driving infrastructure upgrade in the base. But part of that is also these sorts of services drive consumers to higher speed tiers and providers who offer higher speeds. Certainly, one does not get a broadband connection just to talk to other people in your neighborhood. Your utility is based on the set of services that you can deliver off of it. Certainly, a product like Netflix, where they have the highest tier of encode that can be delivered is today roughly 5 megabits per second. If you're on a DSL line, your Netflix experience is not going to be that great. But if you're on a cable modem and you can get 5 megabits per second on a relatively sustained basis, you're going to get a better experience. And if that Netflix experience is valuable to you, you're going to move to a provider who has given you better capacity. And so it's a factor that drives value. Carriers are profiting too if they have good cost structures. One of the amazing things in North America, if the large cable operators, if you read Wall Street analyst reports of their cost structures and their profitability, they generally have gross operating margins on broadband data in excess of 90%, which is not net, but certainly not a bad business to be in, right? So I think we have seen that this era of abundance is good for many people. It's good for content providers. It's good for service providers, driving people to higher and higher speeds. And as long as the cost structures can be controlled, it can be quite profitable. And that's something that we look forward to as a service provider in Kansas City, where we expect to deploy gigabit access service, fiber directly to the home, where Google will actually compete with Time Warner Cable and AT&T directly. Now, one of the questions is, can this trend continue? Are the best days behind us? Or are they actually in front, right? Routing continues to scale. We see equipment coming out from all the top tier vendors that really has improved in terms of performance, but cost structures people are beginning to worry about there. One response has been to redesign the networks in a way as to minimize the number of these very high-performance routers that are needed by basically putting in relatively inexpensive MPLS switching in the core and putting the kind of core, really expensive switching on the outside, and reducing the total number of routers that have to handle very high-speed interfaces. Another thing that's going on in this area is Google and others are advocating OpenFlow, which is a model that separates the routing and computation and management plane from the actual forwarding plane, so that you can basically use much more inexpensive merchant silicon, dramatically lowering the cost of switching, and put the intelligence in servers, right, that are separate from the actual switch fabric. And we think and very strongly believe that by doing this, right, we can scale the network, scale switching in the system, and move to an architecture that is even less expensive, which is going to be important in data centers as well in access. So together, these two factors in the industry, we think, should be able to allow routing to continue to scale without explosions in cost. I don't need to tell you this, but optical transport still has a lot of room to innovate and scale. There's a large gap between what the research community has demonstrated and what's been kind of commercially deployed. And that indicates that there's a fair amount of headroom for optical development. This chart here shows the curve of what WDM research has been able to see in terms of general transport and what the kind of commercial equipment curve is in terms of the ability to move bits across the wire. That gap is something, obviously, that we look forward to seeing get closed, and that as these systems become more mature, go into production, and continue to deliver more and more capacity in the infrastructure. On the access side is an interesting conversation, because we, by and large, do not see fiber in the access network. And so one of the questions is, what's going to happen here onto the on-ramps, right, the things that consumers use? Copper technologies are obviously going to have a problem, right? While DSL technologies continue to kind of modestly scale, particularly outside in the US, if the pace of bandwidth demand and growth continues, you're going to run into fundamental limits of the technology. DSL performance is limited by the quality of the loop and the distance from the DSLAM, both of which US markets have more challenges than what you would find in other parts of the world. But I've given you a couple graphs from, used with permission, from Craig Moffett in a research note that was put out in May of last year. And on the left-hand side, you can see US broadband subscriber flow share. What that means is, over the span of time from 2008 there to 2011, what the breakdown is on the left, what the breakdown is of new ads, new broadband ads. So with the top line, the blue line, are additions of cable broadband subscribers. And on the bottom line, we see additions of DSL or fiber, right? So ATTU verse, Fios, et cetera. So what we've seen is the cable infrastructure basically dominating new broadband ads, right? And so that's now reflected in broadband subscriber share by technology. Again, cable on the top, the DSL being the green line in the middle, fiber loops on the bottom. If I remember correctly, the start of his paper starts off with the line that says, "We are no longer seeing the obsolescence of a product, wireline voice. We're seeing the obsolescence of an entire network, And so this is, I think, the future, right? Provided that there's a competitive environment from either cable operators challenging or fiber operators challenging, this is what the future holds for carriers who stay fixed with the DSL plant. Cable is scaling well for now. Cable networks with DOCSIS 3 are improving speeds without a lot of CapEx increase. DOCSIS is actually quite a nice platform. I helped in the at-home days to write the spec. And it's very extensible. Today, you can bond a number of channels together, and being able to deliver very high speeds in the forward direction. Reverse spectrum in the HFC plant is a limit. And ultimately, the asymmetry that we find in the HFC plant is going to catch up to you, right? Today, the economics are such that even in the kind of less developed countries, the economics of fiber deployment versus HFC are now that no one is going to build a new HFC network, right? People are going to deploy fiber-based solutions as the cost of the photonics has gotten so cheap and the equipment has gotten relatively expensive. I don't believe we're going to see new HFC networks be built. Now, that doesn't mean that there's not a nice business in supplying the existing HFC network providers who are going to be around for a good long time. But the economics of FTTH now clearly have crossed a threshold that HFC is going to be a technology for the embedded base, but not for new builds. Many carriers make the jump to fiber just to get beyond DSL performance issues or outside plant problems, but not necessarily providing step function increases in performance. Certainly with the kind of scale we see in terms of gigabit, in terms of bit transport and inside Google, and Google is very focused on cost-effective compute platforms and on optical transport. Many of you here have worked with our company, and you know our fetish about driving costs down in the infrastructure. And so I think delivering a gigabit today is now commercially quite viable. It's not just because of decreases in the optical ecosystem, but because of all the other things that we're seeing in terms of transport out of market. I didn't mention this in my slides, but content delivery networks are also helping the internet scale very significantly. I think the last charts I've seen have seen something like north of 45% of bits delivered in the US being delivered through CDNs, where people take basically servers with storage, deploy them on the edge of the access networks. This is a good deal for everybody, by the way, right? Because the access provider doesn't have to haul that traffic, nationally pay transit for it, et cetera. The provider, the content distributor gets a good deal off of it because you've got more the users are now closer to the content, closer to the servers, and get a higher quality streaming experience. And certainly, for our perspective, we don't think gigabit service is an endpoint. Every time somebody says there's no need for something more than a certain number, they're always humiliated in some speech, right? That happens 10, 20 years later. The Bill Gates 640K quote, nobody needs more than 640K of memory. We think the optical infrastructure is, once you put in the cable plant, it's not going to be obsolete in a decade or 2 decades. The electronics will change, but the plant itself is going to be able to be viable for quite a long time. And therefore, we need to have a path to evolve that, not just to a gigabit but past a gigabit to 10 gig and beyond, because we don't believe the age of abundance has to end, and we want to help drive it forward. A couple other things. People always ask, well, what applications are going to drive gigabit access? What is going to cause consumers to drive it? Let me just say, we don't have a silver bullet inside Google. We don't have some secret program going on that is a gigabit killer app that once you put it out, everybody will demand it. Our experience both with our test network at Stanford and with talking to other carriers is that people will do mostly what they do today, just a lot faster. And they'll do it more often. One of the first users that we hooked up in our test system at Stanford, after he was connected, he said, well, where do you run a speed test? Okay, you're getting about 900 megabits a second, actually 950 in that case. And then he proceeded to go to iTunes to download a movie. So he buys a movie, and iTunes says, well, it's going to take about 2.5 hours to download. And it was done in less than 5 minutes, which was quite impressive. His response was, wow, I guess I can do this a lot more often. Because the experience now of having that kind of bandwidth that you can throw at even just problems that they were doing, that at applications that he was already using, would change behavior. At a gigabit, we also see that homes are effectively now part of the cloud, right? So as we have these large-scale data centers being built, and not a virtualization layer, but a service layer that allows cloud-based applications to interact, you can now variabilize most of the cost of your application, right, by running it on the cloud. So you don't have to put in a lot of fixed infrastructure to be able to scale. And so when access now has connectivity to the cloud that approaches the speed of processing elements inside the cloud itself, all kinds of new abilities come out. And we think that's going to be something we're really interested in watching and seeing. Also, your normal sort of pedestrian SATA drive that you can get today can stream data at about 100 megabytes a second, which again is about the speed of a gigabit network. And so if you think about what that means, right, when the cloud is connected to you, you are connected to the network at the speed of your hard drive, right? Lots of interesting things become possible, empowering new models for computing and ways of delivering media. I should also point out something that's oftentimes, for some reason, I don't think people understand. The mobile revolution, mobile broadband, is critically dependent on fiber. As mobile traffic grows dramatically, you're going to have to solve the problem by subdividing cell sites. If you look at many of the growth curves that people have talked about, 30x, 50x in 5 to 6 years on the mobile side, you can't get there just by adding spectrum. There's something on the order of 280 megahertz of CMRS spectrum deployed in the US today. Just doubling that, putting another 280 megahertz. Now I have, okay, it's not 50x anymore, now it's 25x. And we go to LTE, right? And LTE Advanced give us better modulation, better technology for that, maybe another 2x or 4x off of that. But it's not something that scales, right? The only way to solve this problem is by reducing cell sites and making them smaller and smaller and smaller. Interestingly enough, Mobidata released a white paper on Wi-Fi offload at the recent MWC conference in Barcelona. It contains global stats, but in the US, of the 4 big carriers, big wireless operators, with the exception of Sprint, all of them are offloading more than half of their smartphone traffic onto Wi-Fi today. And I think the stats said AT&T was offloading more than 65% of its smartphone data traffic via Wi-Fi. Pretty amazing for a technology that was really not designed to do what most people are using it for today. If you, in the limit, right, the cellular network will look like Wi-Fi today. It will go to smaller and smaller cell sizes, and those cells are going to have to be connected at very high speeds to provide that offload. So while wireless is in the ascendancy today, everybody is really prefers to invest in wireless networks as opposed to the old wireline business. Ultimately, the future ability for wireless to scale depends on a robust fiber infrastructure to provide deeper and deeper backhaul and offload of traffic. If that does not happen, it's not going to be cost effective to split cell sites, and ultimately we're going to run out of gas in the mobile revolution. Optical engineering is going to empower the internet to scale. That's what you guys do. And I want to thank you not just for letting me speak, but thank you on behalf of the internet for all of your work. Because most people who click on a website and download a YouTube video, et cetera, don't actually understand that it's folks like you who are responsible for their ability to do that affordably. So I want to thank you for that. I also have a special message from a friend of mine who runs a small company that is very dependent on this age of abundance.
Hi, I'm Reed Hastings, CEO and co-founder of Netflix. And Milo asked me to make this short video for you. I couldn't be there in person. But when we started 14 years ago with DVD by mail, we always looked at it as a high latency digital distribution network. And we waited and waited to get to a low latency network, i.e. streaming. And we started that in 2007, and it has grown like a rocket ship over the past couple of years. We now have tens of millions of streaming members around the world, over 2 billion hours of streaming video in Q4. And of course, all of that work is due to the amazing networks that we have and that we will have. I think everybody at the conference, as well as myself, knows that what we're seeing is a very fundamental revolution, that it's only begun. And when there's fiber to several billion homes around the world, we'll look back at the beginnings at this stage of the market and of networking and be amazed that we all got to be part of it. And I just wanted to get a chance to say thank you to all of you who work to do many things, one of which is to make Netflix even more enjoyable for all those subscribers.
So in conclusion, I would like to make the case, I think I have made the case, that we are living in an era of bandwidth abundance. We've been able to scale the internet successfully, not through large-scale price increases, but through dramatic reductions in unit cost. And that has all been driven by the power of technology and innovation to be able to push more and more traffic through this infrastructure without dramatic cost increases. New internet businesses like Netflix and others have grown up and are flourishing. Consumers are choosing higher speed connections because of these kind of services. So it's a positive ecosystem. We in the industry are going to have to continue to deliver these speeds I think, without expectation of dramatic revenue increases. Certainly, that's how we have designed the program on the access side. I believe gigabit going all the way to the home is only a matter of time. Leaders will get there first. So thank you for all your work. Thank you from Google. Thank you from Reed. Thank you from the internet and from the consumers who have all benefited from the work that you have done to create this era of abundance.